When you ask Alexa a question, it feels like you are talking to a thinking agent. The assumption that voice equals intelligence drives many system designs today. But the reality of how these devices work reveals a very different engineering story. They do not reason or feel, they execute a rigid pipeline optimized for speed over understanding. This distinction is critical because mistaking a latency-optimized script reader for an intelligent mind leads to catastrophic failures in production environments, causing developers to build systems that are either too slow, too expensive, or dangerously unresponsive when users need them most. The core of the misunderstanding lies in what we call the lexical channel. Research from Stanford and Together AI shows that current voice assistants operate almost exclusively on this pathway. They hear your words, transcribe them into text, and then match those characters to a predefined set of commands or simple logic trees. The system ignores non-lexical cues like tone, pitch, or emotional distress unless explicitly programmed to do so in very specific ways. In practice, if you speak with urgency or cry while asking for help, the device processes your words, but often misses the gravity of the situation entirely because it is not analyzing emotion, it is only matching strings of text against a database. This creates a dangerous gap where users believe they are being heard on an emotional level, while the machine remains blind to context that could be life or death in safety-critical applications. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This architectural choice is not accidental, it is forced by the hard constraints of inference latency and hardware capability. For a voice assistant to feel responsive, it must respond within sub-500 millisecond windows. Achieving this speed requires small, fixed models that run on edge devices or low-latency cloud endpoints. If you attempt to swap in large generative language models for every interaction to gain true reasoning capabilities, the system becomes bogged down by heavy GPU requirements and significant processing delays. The result is a conversation where users stare at silence while the device thinks, breaking the illusion of natural flow. Consequently, engineers face a brutal trade-off: deploy a fast but simple pipeline that misses nuance, or build a slow but smart engine that frustrates users with lag. Most legacy systems, and even many newer real-time implementations, choose speed because human patience for conversational delay is incredibly low. The consequences of this design philosophy extend beyond mere annoyance. They fundamentally alter how humans interact with technology in ways we often underestimate. Studies indicate that over 40% of users treat these devices as predictive authorities regarding their own behavior and needs, even when the logic fails repeatedly. This phenomenon creates a faith in AI, where people attribute feelings or independent will to machines that are merely executing scripts. The data suggests this misattribution is not limited to children. Adults frequently trust systems with limited reasoning abilities as if they possess genuine cognitive agency. When a system based on a lexical pipeline encounters sarcasm, distress signals, or complex emotional contexts it was never trained to handle via text matching, the failure mode can be severe because the user assumed the device understood more than its architecture allows. The statistics from behavioral studies on human-computer interaction highlight just how deep this blind spot goes. In one significant study involving over 1,300 participants, researchers found that a substantial portion of subjects attributed agency to these devices in ways that led them to make poor decisions. Specifically, data showed a 33% increase in odds for users foregoing guaranteed rewards or safer options because they trusted the device's output as an authority. This blind trust resulted in earnings reduced by between 10 and 42% in experimental settings where participants relied on flawed logic from these assistants. These numbers are not just academic. They represent real-world engineering risks when developers assume their voice interface has a brain rather than a pipeline. For software engineers, the takeaway is that you cannot design a robust voice interaction assuming the backend is an LLM unless you explicitly architect for it and pay the cost in latency. If your system relies on standard speech-to-text pipelines, which most do due to hardware constraints, you must account for the lack of emotional context and the inability to handle sarcasm or distress without explicit prompts. The choice isn't simply between dumb and smart. It is a trade-off between sub-second responsiveness and the compute cost of generative reasoning that requires heavy GPU resources. Understanding this difference is now a critical filter in modern AI engineering interviews and architecture reviews, as confusing signal processing with cognitive agency will lead to systems that fail when they matter most. The path forward for practitioners involves recognizing where hardware choices force software limitations rather than trying to hack around them with bigger models on small devices. You must design interfaces that acknowledge their own lack of understanding or explicitly guide users toward actions the system can reliably perform without assuming hidden knowledge. As AI continues to evolve, the ability to distinguish between voice interaction as a signal processing task and intelligence as reasoning will define which engineers build systems that are truly useful versus those that simply sound smart but break under pressure. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.